Hey class, this is a quick recap video of our lesson today for geometry. We are focused on lesson 1-4, midpoints and bisectors. This particular set of notes is much more focused on midpoints. We'll work on bisectors tomorrow. To start off with, we just thought about what midpoint means. Midpoint is the middle point. To find the midpoint on a one-dimensional number line, we just need to know two locations, x1 and x2. To do so, if we know those two locations, we just add our x1 and x2 and divide by 2. We approached it a little bit more by plugging in some numbers. We said, let's call x1 -5, and x2, let's call it 13. We then averaged the two numbers. We said -5 plus 13 divided by 2 gave us a location of 4. So our middle point would be at 4 on the number line. This would be, to be clear, a location on the number line. The 13 is a location, a coordinate on the number line, and -5 is a location on the number line. Now, M is the midpoint, it's the middle, it's between A and B. It is equally between A and B. A way to visualize that is if I had A and B, the distance from A to M and the distance from M to B would be the same distance. You can sort of see that. -5 to 4 would be a distance of 9. This would be 9 long. The distance from 4 to 13 would also be 9 long. Because these lengths are equal, we would write that as AM. The distance from A to M is equal to the distance from M to B. I just did also a little bit of callback with you guys about some other language. If I didn't want to talk about the lengths, if I just wanted to talk about the two line segments, AM and MB, if I wanted to talk about AM with the bar over it and MB with the bar over it, we would say those two line segments are congruent, and we'd put the tick marks to indicate that they're congruent, and we'd use a congruent symbol in between them to say the A to M is congruent to M to B. Here the line segments are congruent, here the distances or the lengths of the line segments are equal. Just a reminder about those two small ideas. This was for a one-dimensional case where we just looked to find the middle. I want you to then extend this to 2 dimensions. To do 2 dimensions, it's the same formula. We're just going to average the x's and average the y's. We're going to do those separately. Let's take a look at example 1. Midpoints in the real world was our sort of first focus. Mariel is going to work at a vintage clothing store. She wants to hang a new sign so it is centered above the dressing room door. We see some important measurements already done. We see the distance from the corner of the room to the first side of the dressing room door, the left side of the dressing room doors, is 7.5 feet. And the distance from the corner to the right-hand side of the dressing room doors is 13.5 feet. Given that these doors have the same width, we want to find the point along the wall that Mariella should hang the sign. We want to know where we could put a nail in the wall. We want to point where a nail can go in the wall so that this sign will be hung centered on the doors. Well, while these are distances of 7.5 feet and 13.5 feet, because we are measuring from 0, x1 also happens to be the location 7.5, and x2 also happens to be the location of 13.5. We can just average these two locations to find a middle point that would be some distance away from the wall and would be centered here. We'll average our 7.5 and our 13.5 by adding them and dividing by 2. We'll just get 21 over 2, or 10.5 feet. So Mariel is going to put a nail in the wall to hang the sign. It looks like 10.5 feet from... She's going to hang the sign 10.5 feet from the corner. If this is the corner of the room here, and it looks like it's the corner of the room, she's going to hang it 10.5 feet away from that corner. That should be where the center of the dressing room doors are. Now let's take a look at the Now You Try here. Kenneth's traveling from his school on 38th Street to the library on 62nd Street. He's going to stop halfway to take a break. We want to know where he's going to stop. Visually, we can sort of already see he's stopping right here in the center. From 38th to, looks like 50th to 62nd. But we shouldn't just go based on the picture, we should also do the math. Since 38th is a location, I can call it x1, and 62nd is a location, I could call x2 if I desire. And we can just average our street numbers. We can go 38 plus 62 over 2, and we'll get that it equals 100 over 2, which is the same as 50. Which means 50th Street works. 50th Street is the halfway point. Now, I did sort of extend this idea in class with you guys. You didn't necessarily write it on the page, but I did extend the idea a little bit with you guys here. I posed another hypothetical idea, and I'm going to zoom out so we can add on to another sheet of paper. I said, let's also imagine maybe Kenneth is part of the swim team, but the school doesn't have a pool, so he has to go to a YMCA. All the way over here. Here's the Y. Now, I've not given a location for where Kenneth's YMCA is, but I could tell you that Kenneth takes a break on his walk at the library, and that the library is the midpoint between the school and the Y. We can make use of the fact that the library is the midpoint. It's the midpoint between school and Y to find where the Y is. If you know how far it is from the school to the library, and we can sort of see that from 38 to 62nd, we can see it's 24 blocks. We can repeat the same process. Because again, since the library is the midpoint, the distance on either side has to be the same. If we got 24 blocks here, we need to have 24 blocks here as well. So we can add 24 blocks to our location at 62nd Street and get the Y is going to be located at 86th Street as well. We're going to finish up with our last two examples, example 2 and example 3. Example 2, you guys basically are done without me. I didn't have to say a thing other than just use our formula. We have 2 points A and B. We can just use our formula. We'll say we've got x1, y1, and x2, y2. We'll just add our x's, -2 plus 8, and divide by 2. And we'll add our y's, 1 plus 3, and divide by 2, making sure to put some parentheses around to remember that it's a coordinate. We'll say it's 6 over 2 and 4 over 2. We'll simplify those to get 3, 2. In one of the class periods, I did put the letter M here just to remind us that it's the midpoint. On a test, you would not generally have to put M, is 3, 2. You would generally just have to enter the coordinates. Example 3, I talked about 2 different ways in classes. The first way is, I think, my favorite way. We're going to be finding the missing coordinate. We're going to find where A would be located if P is the midpoint of A to B, and we know where B is located. My favorite thing to do for this is draw a picture of the situation. So I'll draw a line. I'll place P right in the middle because P is supposed to be the midpoint. And I will label its coordinate as 3, 1/2. Now I'm going to place B over here to the right because it has the x coordinate of 8, which would be to the right here. So B is over to the right, and it's at 8, 3. We don't know where A is, so I'm going to give the coordinates x, y. That's the x and y we want to find. You can almost now look at this problem as a pattern. Because you know P is in the center, however you get from whatever steps or slope you take to get from B to P, you're going to repeat to get from P to A. We're going to go from 8 to 3 just by subtracting 5. If we're going to go from 8 to 3 by subtracting 5, that's going to get us from B to the point P. We're going to do the same thing to get to our x here. We're going to subtract 5 as well. 3 minus 5 will give us an x of -2. We do the exact same idea with our y's. To go from 3 to 1/2, we subtract 2.5. To get from the 1/2 to the y value at A, we're going to subtract 2.5 as well. We also end up with y equals a -2. We did sort of briefly see this by setting it up using our... This is my preferred method. This is just how I mentally think about these sorts of problems all the time. But we can approach the method by setting up a little bit of a system of equations as well. If we write our coordinates, plugging in what we know, we don't know what A is, so we'd say we've got x. We're going to write our problem using midpoint formula. We're going to average A, which we don't know, and B, x plus 8 over 2. We're going to average our y's. We don't know A is y, so we're going to say y plus 3 over 2. That coordinate that we have here should be the same as our 3, 1/2. Because if we have the midpoint formula here, it should be the midpoint, which is 3, 1/2. Well, once I see this, I basically write 2 separate equations. I'll write x plus 8 over 2 equals our 3. I'm just comparing the x's. And we'll solve that, getting the same answer over here. And we'll set up y plus 3 over 2 equals 1/2, and we'll solve that equation, getting the same answer we have here. both methods work. I mentally do the stepping sort of pattern slope sort of approach most of the time when I'm trying to do it mentally, but there are situations where a problem like this is best solved with the basic ideas of what the midpoint formula looks like. You had some homework on the back to go with this. I'm going to show just what the homework looks like on the back because some of the copies made it hard to read off two graphs. So we're going to take a look at 54 and 55 on the back, just so you have a chance to see the pictures again. Here's question 54. Sorry about that. The lights keep trying to go out. A computer software designer is creating a new video game. The designer wants to create a secret passage that is halfway between the castle and the bridge. Where should the secret passage be located in this case? Here we can see the bridge using our coordinate grid. Here we can see the castle using our coordinate grid. 55. Pablo is going to ask Bianca to prom by sending her on a scavenger hunt. Fun. At the end of the scavenger hunt, Pablo will be standing halfway between the gazebo and the ice cream shop. Where should Pablo stand? Here's where the gazebo is supposed to be located. Here's where the ice cream shop is supposed to be located. Those were 54 and 55, just in case you have copies where those numbers didn't quite appear.